This is Dr. Carroll. This video is about static variables and methods. I remember as a college student learning to program, one time I was working with a project and I had made a naive mistake and had written lots of code and then was trying to force it through the compiler to get it to work. And it was throwing errors about you can't call this from a static method, so I started putting static everywhere and it just wasn't making sense, and it was causing ramifications and it just wasn't working. So let's clear up some of this, and so you can learn from some of my mistakes and what is static and how to use it. Well, first off, static is a key word, okay? And so it's a keyword, and it means only one copy per class, okay? So let's start by talking about static fields or class variables, okay? So this is a variable of a class, and it's not, and so to be clear, it's not a class instance. So it's a variable of the class as a whole, but not an instance of it, not an instantiation of an object. So the class variable is declared and initialized during class definition. And this is different than an instance variable, which is declared and then space is given for it when the object is declared and it's initialized in the constructor, typically. And so this makes the variable available to code inside of the class. It also makes it available to code outside of the class, but we can use it, but to get at it we have to use a special notation. And so we use the class name dot and then the member of operator as the static field name. So for example, here's one you might recognize, math.py. Okay, class name is math, and then pi is a static field name. And so, and we can use these variables independent of an instantiation of the class. For example, here we don't have a new math object and then call pi on it. We can just say, hey, math.py, it's a constant, it doesn't change, and so it's independent of any instantiation of a math class. These are rarely used in code. There's only a few exceptions that make sense, for example, with the math.py. So let's see an example of this. So if we felt like we were going to use this, we had some simple bank account here, and we had our balance, which is an instance variable, and we have our constructor that initialize it. Well, we could put in a variable that is a class variable, so it's going to be independent of all of the instantiations of it, and it'll be one per class. And so let's say it was the number of accounts, and I don't know what happened to my color highlighting there, sorry. And then we could, for example, in the constructor say, hey, every time we make an account, we're just going to up that account. So as we instantiate an object, it will call the constructor. So let's keep this example going with math.py I already mentioned, or system.out. So out is a static variable, a class variable, a field, a static field of the system class. And so we can access that, and we have with system.out.println and other things like that. And so those are some examples. So the math class has no instance variables, and so let's just take. So here we have the Java documentation. I'm looking at the math class. You can't tell it's the math class. So yep, there it is. There's the math class. And so if we look at the field summary, and so we have a static E for the constant E, and then we also have a static double pi as well. And while we're here, let's just look at the methods we have as well. So we have static methods like absolute value, arctangent, ceiling, floor, hypotenuse, log, log base 10, max, min, a whole bunch of different methods. And notice we don't need to call new on a new math object to be able to get at these. We can just say math dot and then reference them because they're independent of any instantiation of the classes. So now let's talk more about methods. So when declaring a method static, it means that the method is independent of any class instantiation. And so this can be good when we use this, is when we want to have a method available and not be able to instantiate any object. So we've seen some examples of this with math, for example, absolute value and a host of other ones. And then it's the same thing with the system class, system.exit, etc. And so we don't have to have a new system call before we can call system.exit. We can just use it. So there are some rules with static methods. One is static methods cannot call non-static methods in a class. So in a class, if you have a static method, that means it can't call the other, it can't call other methods in that class that are non-static, because the non-static methods won't have instance data available to them potentially. That we've called them independent of any instantiation in the class, and so they could have instance data that they're relying on, these non-static methods, but then you can't mix it, and so it just won't work. So let's look at an example of that. If we have our simple bank account example again, and we have our number of accounts, our static variable here, and we increase the number of accounts, then we could have a static method that says, hey, I want to know how many accounts there are. And so we could have a public int get number of accounts, but what we need to do is we need to make it static so that it can get at the static variable, and we can call it independent of any account. And then it would just return the number of accounts here. Okay. We could have also had something like, hey, valid account number, so we wouldn't need it tied to any instance of an account. We could just say, hey, I'm about to create an account. I have a customer that wants to know if this account name is valid, and so it's independent of any account. We just want to be able to call it, say, boolean yay or nay that it is valid. Or another one might be customer service phone number. That's independent of any specific account, and so we could just make it static. So let's look at a little animation of this. So if we have our class definition here, as I was just showing, a bank account. So we have our balance, and this is an instance variable. So, but then we have a static number of accounts, and we have different methods. One of them is get number of accounts. So the bolded method and field here, they are ones that we can get at just with the class definition, independent of any objects. Now, if we instantiate an object, and the way we have it written here, in the constructor, it would increase the number of accounts to 1. And so notice the bolding and the graying out changed here. In an instance of a class as an object, we have a balance, and we have these methods available. We can use that one as well. But we don't have a copy of number of accounts. It only lives up here. And so if we create another one with a larger balance, then our static variable here is keeping track of all these things, and then the third one here, and then the static field here is keeping track that we have 3 of them because it was created in the constructor. That concludes this video. I hope you enjoyed it.